I gave you the graph, come on, you're a smart board. F of x equals 1/2 to the x. Alright, now this is difficult here, but what I'm expecting you to do is remember back to exponential equations. Remember an exponential equation started off in the form of y equals ab to the x. Remember that? And our b is what told us if we were going to be a growth or decay. So right now, what's my b?
1/2.
1/2. Okay. What's the a would just be 1, but I'm not worried about the a right now. The b is 1/2. So that 1/2 is less than 1. So would this be a growth or a decay? Okay, y'all still got notes on that? Y'all remember that? Everybody good on that? Okay, so we could graph this, and I got an idea. It would probably look something like that, right? I didn't draw the axis, but just the shape of the graph, right? Maybe similar to that. All right, so now if I gave you g of x is equal to 1/2 to the x plus 3, and asked you what happened to get from f of x to g of x. It's the exact same transformation that we've seen on every other kind of graph. We've got a plus 3 stuck on the end. When plus or minus is stuck on the end, it scoots it up or down. Plus scoots it up. So we would just say it slided 3 units up. It translated 3 units up. Okay? Now what's a little bit different on this, I put a 2 on that one instead of an x. Still, I don't know why, because I'm stupid. Still has to be an x to be an exponential. Your variable has to, your exponent has to be a variable. But what's different, that's what I was about to get to, is where the x is. So remember before, if we like if it was a quadratic, y equals x minus 2 squared plus 3. This one will be scooted up 3 and right 2, right? And the x is there. But it's different now that the x is up there. To scoot it left and right, you still got to be with the x, but so you'll be on the exponent. I just totally confused you. Let's go back.
So exponent is left and right.
Let's go back to that original one. This time g of x where's the plus 3 this time? Is it good? It's not just stuck on the end, it's still in the power. So it's up there with the x. So what would happen from f to g this time? Scoot left 3, very good. Okay? I remember our transformation stuff.
So the first one that you wrote down would just be up 3?
Uh-huh.
Wait, would you put the decay with that too?
Well, if they asked you which one it was, yeah.
Oh, but they...
Alright, let's look here. We're going up, we're going over. Let's see, there's some e's at you. F of x is equal to the number e to the x. G of x is equal to e to the x plus 3 plus 2. It's that easy. See, it's the exact same as every other type of function that we've graphed. The rules for scooting them and flipping them and stretching them and shrinking them are exactly the same. So Kylie said this is left 3 and up 2. Everybody okay on that? All right, let's get some of the other ones now. Those have been all the scoots. The other ones are sometimes harder to remember. Got what you need on that one? Alright, I got f of x is 3 to the x. g of x is 3 to the 3x minus 5.
Is it like a stretch or shrink?
Yeah. It's going to have a shrink or a stretch. Let's go ahead and get the easy one first.
So the right pretty much.
Right 5. Okay, because the minus 5 is up there with the x, correct? So we know it's going to go right 5. All right, now the shrink and the stretch, and this is the trickier one to me every time. I always have to make some notes on that. When it's, make sure I tell you the right thing. I don't want to have to go back. Horizontal or vertical is the first thing that I'm trying to decide on. This one is going to be horizontal because it is yes, because it's the different. And this, I'm trying to think of how I can put contracts dumb words for y'all to be able to pick up on. The difference for me on telling if it's a horizontal or a vertical shrink or stretch is parentheses. If it's vertical, to make it stand out to me, there's always parentheses to tell if it's a shrink or a stretch. So we would like have that 3 to the 3. It might look something like that. You know, there'll be a parentheses involved. Okay? If there's not a parentheses involved, it's horizontal. And that's not very good mathematical terms, but that's why I was stumbling there trying to put it into mathematical terms. I can't find any. But everybody, now, so we know, let me erase that vertical so you don't get confused with which one we're looking at. We know we're horizontal. Now, is it a horizontal shrink or is it a horizontal stretch?
I feel like it's horizontal opposite or vertical.
That's the thing, and Macy's remembering on that.
It would be a shrink, right? It's horizontal opposite.
Yes. How's it opposite though? It's not exact. You think the right thing, but it's not. Opposite's not the right word, but you're thinking the right thing.
Greater than one, so I would think it would be a stretch. Horizontal opposite.
What'd you say, Kylie? Oh, I thought you said. It's a horizontal. Greater than 1 means it's a shrink. That's where Macy was. She was thinking. That's why she was saying opposite. I was trying to make her say something else that she wasn't. I just now understood what she meant. Your A here is what's you're multiplying by 3. If that's greater than 1, it's a shrink when you're horizontal. If it's less than 1, it's a stretch. And that's what Macy was saying by meaning opposite, because greater would make you think bigger, you need to stretch it. That's what she was saying. Less would make you think it's smaller, you need to shrink it, but it's really not. You got to think the opposite way. Now, what I was trying to make her say, what I was stumbling on, and when it's horizontal, it shrinks or stretches by the reciprocal. So we don't say a horizontal shrink of 3 on this. We say a horizontal shrink of 1/3. And that is a big note that you would need to remind yourself of. When it's a horizontal shrink or stretch, it's the reciprocal.
So even if it was like, that was like 1/3, you would have to change it to stretch of 3.
Uh-huh. But you don't, on vertical, you don't take the reciprocal. You take what it is. Horizontal shrink or stretch, you take the reciprocal. Yeah, I'm sorry, Anna. I didn't know. I gave up and scribbled how to spell reciprocal. That's one of my tricks. When I don't know how to spell, I write even messier, so maybe you won't notice.
Yeah, I have no idea that. Reciprocal.
It's reciprocal. My dad would beat my butt right now. Just because I didn't put an A doesn't mean there's not supposed to be one.
Let's Google it earlier.
That's funny.
It is R-E-C-I-P-R-O-C-I-P.
Everybody got that?
Nope.
We need to have that copied so every time
Yeah.
you have to write it.
That looks like she has just a coordinate.
Yeah, that's what I was thinking.
Used to be a.
Oh, there you go. Oh, that's what you need to try.
Yeah, but how you know how often this thing recognizes my words?
No.
Let's see if it would recognize this one.
It's gonna say chord of it.
Yeah.
Oh. Well, no, there's no way. There's no way.
It just cheated off of the first time I wrote it. Let's see if it recognizes that. Oops. Whoa, whoa, what did I
They
do?
said we don't know what that is. We're getting rid of it.
Where's the undo button?
Up at the top?
Yeah, but it's not there.
No, over.
That's the redo.
Oh, I thought it was just like,
Oh,
oh.
it won't let me even redo.
It's so bad it won't let everything.
Okay, well, we're going to move on now. That's scary. Log, if I put a log, those were exponential functions. If I put a log function in, it's the same rules and everything. We'll just have the word log with our graph. If f of x is equal to the log of x and g of x is equal to the log of negative 1/2 x. All right, now the slides up and down, right and left, and all that is the same. This one's a little bit more difficult than a slide because there's no plus or minus anything on it. What we notice is we've multiplied by a -1/2 in front of the x. And so that means I'm going to be dealing with a shrink or a stretch, right?
Wait,
Whoa. Let's slow down. Kylie, what were you going to say?
with the shrink and stretch, is it the same for vertical and horizontal, or is it different? Like if it's less than 1, it's a shrink? I mean greater than 1.
Vertical's just normal, right? Stretch is greater than 1 and shrink is less than.
I don't know. I can't. Y'all are ahead of me, and I can't catch up right now. What the first? Slow down. Let's go, baby, and go together. The first thing, there is a shrink or a stretch, yes. But the first thing is that negative. What is a negative when we take a negative? What does that do? It's a flip. So we're going to have a reflection here. Okay. So we've got a flip, a reflection, R-E-F-L-E-C-T-I-O-N. We've got a reflection, and that negative, it's important on where it is and on if we're flipping over the x or the y-axis. Okay? That negative is in that parentheses with it. That means it's going over the y-axis. Okay, so we're flipping it over the y-axis. Now, once we get that, we're not worried about the negative anymore. We know we've got a 1/2, which is smaller than 1. So smaller means I'm going to stretch it. Horizontal stretch. And do I take the reciprocal or do I take the 1/2?
But I thought vertical was in the parentheses.
Hold on, I'll talk about that. What, reciprocal or the 1/2? The reciprocal, so it's a horizontal stretch of 2. Now, what Macy was questioning is a good point, because when I put you in Coach Wright's dumb words a minute ago, I talked about that parentheses. Why is there a parentheses here? So I don't get confused with that negative, right? And what did I do when I took the reflection? That took care of the negative. So I'm not worried about the negative anymore, so those parentheses wouldn't be there anymore. It's scary in my brain. Well, maybe somebody wrote me a love note, but they didn't.
Okay, fine.
What would a reflection of the x-axis look like?
It would just be, I'm going to give you one. That's a good question. Reflection of the x-axis. We would go to, I like that. It's all the way out in front of the whole thing. It'd be negative log of 1/2 or whatever x. This would be when I'm a reflection on the x-axis. Look where the negative is. Excuse me, that was a good question, Kylie. Yep, out in front of the whole entire thing.
So since these parentheses don't have negative, then that would be a vertical, right?
Yeah, example be?
And that doesn't take the
She's making up new problems.
Well, I was doing it so in my
Like,
so I have it.
if this were the thing, she would say reflection on the x-axis and a vertical. What'd you say?
The vertical, I said shrink, but I was trying to
It would be a vertical shrink of 1/2.
Sorry.
Do you need? I'm about to choke. Do you need? Listen, hoodlums. I didn't plan on doing this because I thought we could remember it from all the rest of them. But do you need me to write that chart again with logs in there? Honestly, and yeah. So you know, like where it says horizontal translation, what it would look like. Okay,
Yeah,
I can.
Because this is like the simple
Okay.
math.
I got you. I got you. Is it all right if I do it just with logs, so I don't have to do logs and exponential, or you want one or the other, or do you want two different charts? You don't know what I'm talking about. You just want me to shut up.
Just my teacher will.
Yeah, ask my teacher.
How much
Huh? What'd you say?
Well, like if I start on this paper, will I have to go back?
No. Alright, so what we got here, the type of transformation, and then this is function notation, and then this is an example, so this is what it did.
What
So,
did it say?
yeah, this went 4 units to the right.
Oh, okay.
So is that okay? Is that, everybody follow what I'm doing?
So that's the example?
This is the example.
If we were like to title each of those, the first one, you see the transformation.
Yeah.
Oh.
I thought you said vertical did have parentheses.
That's just a slide. That's
Oh.
translation.
So the top one would be vertical and the bottom, top one would be the y-axis, bottom one would be the x-axis, right?
From what I'm writing right now? Yes. Yeah. That's what I was getting to. Did you get those first ones, or do I need to scroll it back up? Okay. It's easy with the logs there to see the big difference in the shrink and stretch on horizontal and vertical. It's the vertical, it's all the way out in the front of the thing. What were you going to say, Grayson?
On the last one, the box after the vertical stretch and shrink, is there supposed to be a dot?
Yeah, times.
Oh.
So whatever you're stretching or shrinking would just be out in front of the function. You're welcome. That's what I was saying before we started. I didn't know if we remembered or needed, but I don't mind.
Yeah, I don't remember, but it helps to have it there.
I'll give you, everybody got what you need on that? Alright, give you a couple more now so you've got something to look at instead of trying to decipher what's going on in my crazy brain. And we'll see if you can get them. Let's do exponential one there. And we'll say f of x equals 4 to the x. And I'm doing an exponential one specifically because I didn't write down an exponential chart just to see if you can compare it to your log chart. This one's an easy one though. G of x is equal to 4 to the x minus 8.
Oh,
I wrote that.
Not right 8, no.
oh,
Down
yeah, I wrote it
Down
down
eight.
with the X.
Okay, because this minus 8 is not up on the exponent with the x, it's just down on the end. So this one would go down 8 units.
I was listening, and,
Yeah, that's what I did.
and I was like, oh, well, that's good to know.
Because it was with the exponent and it was equal to.
Then it would have been right 8. Okay, let's look at a log one. Let's see if this confuses
You said it like you wanted.
you. No. Let's see if you remember something from Monday.
Today, Wednesday.
Alright, that chart that we made just a second ago, and this is what I was mumbling to myself to see if this confused you a little bit. The chart that we made just a second ago, all of the logs that you wrote had a base of what? 10. I didn't put a base in there, they were understood base 10. This one has got a base of 1/3. The rules are still the same. I just changed the base on the log, so that didn't confuse you, no problem on that. Alright, what tell me something that we got going on here.
Reflection of the y-axis.
Okay, we've got a reflection on the y-axis. Kylie is right. Everybody see that? Not an F-E-F, R-E-F. Reflection on the y-axis. Okay, and then up 6 is what they said over here. Is that everybody good on that? You'll need a shrink or a stretch one. That's what y'all get confused on. Let me find a good one of those. There we go. Alright, last one if we can do alright. Everybody got what you need there? I got f of x equals log of x and g of x equals negative log of 7x. Alright, what we got?
Oh, reflection on the
Okay, Macy's right with the reflection on the x-axis. Everybody see that? The negative out in front of the whole thing.
And then it's a shrink of 1/7.
And then it is a shrink of 1/7. Good. What's kind of shrink?
horizontal.
horizontal. Good job. Everybody see what Kylie and Macy got on that?
No, I'm right.
Okay, we're paused for you. Tell me what you need me to do. Look.
Say the white part.
We got the reflection of the x-axis because the negative out from the whole thing. Then we got the horizontal shrink of 1/7. We knew horizontal because we had that parentheses involved. 7's bigger than 1, so it's a shrink, and then you take the reciprocal.
I saw the word graphing when I walked in this morning. I thought we were graphing there.
No, others are that.
Well, if I were told to graph any of those things that we did today, I'd do it, and I'd get an A, and you would too, because all you do is plug them in your graphing calculator. All right, everybody all right on the transformations?
Can I look at your number 4 now? Yeah.